Okay, here is our video recap on solving for exterior angles of a triangle. So we have a warm-up. We're going to take some quick notes. We have one new Khan Academy to add to the list. There is a Big Ideas online assignment, and then the exit ticket 4.3 on Canvas. So our goal today is how do you solve for angles of triangles? So grab a warm-up paper, and you're going to measure and label each interior angle and classify the whole triangle by angles. So just to review how to use a protractor. Remember, you line up the little center dot on the protractor on the angle. Make sure the line is overlapped on the side of the triangle, and you should be able to see the angle that you're measuring on the inside of the triangle. So when I extend this, it's a little bit more than 40. It is 41 degrees. If you ever get the two numbers confused, remember this is an acute angle. So out of the 40 and the 140, it's going to be acute, so it's going to be closer to the 40-degree angle. Okay, so measure all the angles on your warm-up. Hopefully you've measured them by now. Let's just go over them. For this angle C, it should have been 37 degrees because it's a little bit more than 35. And again, it's acute, so you're not going to use the 140 number. For this angle, you could probably eyeball it, but it is 90 degrees. And then I had to turn my protractor or turn my paper to measure this top angle. Again, the dots overlapped with the angle, the side is overlapped with the line, and then we just extend our angle. This is an acute angle, so I'm going to use the inside numbers. So it's about 53 degrees. I can double check to make sure all these numbers work, they should all add up to 180 degrees, which they do. So this is a right triangle because I have a 90-degree angle. Okay, let's do the next one together. This bottom right angle is acute, so it's closer to 70 degrees, and it's 71 degrees. Okay, this left angle, I put the angle right there, the line's overlapping, extend it, it's an acute angle, so I'm going to use the inside numbers, so it's closer to 60, it is 55, 56, 57, 58 degrees. If you're off by plus or minus 1, it's okay. And then this top one, I had to rotate my my protractor, and so that my line overlapped. And then I extend this side. It is an acute angle, so it's closer to the 50-degree mark. It's a little bit more than 50. It's 51 degrees. I double check. They all add up to 180 degrees. So since all the angles are less than 90, this is an acute triangle. Okay, this one, this is obtuse, but let's just measure it. If my angle doesn't reach, I can use my pencil to extend it. So this angle on the right, this angle C, it's acute. It's going to be 34 degrees. And the angle on the left, I don't need to use my pencil this time, but it's acute also, so I'm going to use the inside numbers, not the outside numbers. So it is 15 degrees, because it's between 10 and 20, so 15 degrees. And I rotated my protractor. You can rotate your paper. My line's overlapping, my angle's on there. I extend it. I extend the angle. You might need to use your pencil for this. I did. And it is an obtuse angle, so I'm going to use the obtuse numbers. So it looks like it's a little bit more than 30. It's 31 degrees. Double check, they all add up to 180. Again, if you're off plus or minus 1, figure out which angle you want to change. And it should add up to 180. We are humans after all. So this is an obtuse triangle. So let's take some notes. Get your notes out. We're going to do 4.3 exterior angles today. And we already talked about how to classify triangles. And if we don't have the angles, how to classify them. We talked about how to solve for interior angles of triangles. So now we're going to talk about how to solve for exterior angles of triangles. If you can tape this in on the left side of your notes. And then let's just take some quick notes on the right. So what is an exterior angle? I guess we should probably talk about what that is first. An exterior angle is if I extended one of my sides, and it's this angle on the outside, the exterior of the triangle. And if I use a protractor, I can measure this outside angle. It's obtuse, so I'm going to use the outer numbers in this case. I'm going to use the inner numbers in this case. I want the bigger number. So it's 139 degrees. Remember, I already did this one as an example. It was 41 degrees. So one thing you should notice is that these two angles that are right next to each other that form the straight line, they add up to 180 degrees. So now go back to your warm-up and let me have you measure those 3 exterior angles that I drew on there. Okay, hopefully if you need to, pause the video if you haven't. And hopefully you've unpaused the video after you've measured it. But this one should have been 141 degrees. Again, double checking, sorry, 143 degrees, double checking, they add up to 180. Okay, and then check the other two. So an exterior angle, we know an interior angle adds to 180. An exterior angle, it is supplementary, meaning it adds to 180 with its adjacent or next to interior angle. This is this example. So my exterior angle is supplementary or adds to 180 with its adjacent interior angle that they form a straight line with. Okay, so again, that's 143. Now if I cover it up, it's not my hand, but imagine it was. If I cover up my adjacent angle, is there another way to find it? To find out that this is 143 degrees. Hopefully you realize that these two other angles, when I add them together, they're going to equal my exterior angle. These other angles that are not adjacent, they are called remote interior angles or non-adjacent angles. So another way is that the exterior angle sums or adds up to equal the two remote non-adjacent interior angles. So the two angles it's not touching inside the triangle, if you add them up, you get the exterior angle. Okay. Now there's another way to do this. All right, there's another fun fact about this. If I find all the exterior angles, again, you just extend one of the sides. It doesn't matter which way you make it. It's still going to form a straight line. If I extended all my sides and I found all these exterior angles add up to a magical number. So 109, 129, and 122, if you add them up, they all add up to 360 degrees. So exterior angles, they all add up to 360. And that's actually true for any shape, not just a triangle. So fun fact. Okay, so let's use this information to solve some problems. Okay, my animations. Okay, so draw this picture. And here I have two interior angles and I have an exterior angle. And there are a couple of ways you can do this problem. One way would be you could solve for this missing angle because they all add up to 180. And then you could say, hey, this is a straight line, so this angle plus this angle add up to 180. But there's a slightly faster way, and that's using this exterior, the fact that the exterior angle is equal to the two remote interior angles added together. So bullet point number 2. So my 5x plus 10 equals 50 plus 70. Combine like terms, subtract 10, do the opposite to get it to the opposite side, and then divide by 5. Do the opposite to get it to the opposite side. That's a fast way to do it. Again, you could still solve for this angle, which is 60, I believe. No. Yeah, 60. And then this 60 plus 5x plus 10 equals 180, and that's another way you could solve it. Okay, let's do another example. Oh, so here's an example from Khan Academy. Again, what's the fastest way to solve this angle first and then subtract from 180? Or you could just add them together and you'll get the exterior angle. Your choice what you want to do. Here's another example. Let me finish labeling it. Okay. Okay, here I have a triangle with an exterior angle. One thing I notice is that these little dash marks, that means these two sides are the same. So this is an isosceles triangle. Recall last class we reviewed isosceles triangles. These two sides are the same, so the base angles are going to be the same. This is called a vertex angle. It's the different angle. So if I don't know something, I could call this y, I could call this y. Now, on here, I wouldn't use this exterior equals remote plus remote, because then I'd have two variables going on in this situation. I'd have x equals 20 plus y. So this one is a case where I would definitely add them all up using triangle sum and say they all add up to 180. So 20 plus y equals 180, or 20 plus 2y equals 180. Subtract 20 from both sides, divide by 2, y equals 80. So I know this isn't drawn on a scale because I drew it really fast. And then once I know that this is 80, these are both 80, you can either say, hey, these add up to 180, or you could say my exterior angle equals, cover up this angle that's next to it, the two remote interior angles that it's not touching. So this is 20, this is 80. We already know that. So either way, you're going to get 100. Again, the other way is once you solve for this green y, I know this is a linear pair, so add them up and set it equal to 180. And so I get 100 degrees. Either way. Okay. You decide what's fastest, but be able to do both ways. Okay, last example we're going to do. Okay, so I'm drawing a bunch of lines. Basically, I'm drawing a triangle where they kind of extend, so I have 3 exterior angles. And I'm going to label them. I don't know why I use such a large font when I labeled them, but I labeled the outside, so the exterior angles. And remember, when you know all the exterior angles, we know they're all going to add to 360 degrees. And that's for exterior angles. Interior, all add up to 180 in a triangle. Exterior, all add up to 360. So when I plug them in, I have this algebra problem. I'm going to combine like terms. 110 plus 20 plus 10 is 240. And then plus the 2m. I'm going to subtract 240 from both sides, so I have my variable almost all alone. Divide by 2, and I get m equals 60. And then from there, yes, you could still find the interior angles if you wanted to. That's another way. I could have said this is 70, this is 60, solve for this angle right here, and then make that a linear pair. That's another way to do it, and that is correct. Okay, that's our notes for today. There are some extra examples on here that you don't have to do. Let me have you do your last Khan Academy, and then we have a big ideas math problem, or assignment set that's due on Thursday, Thursday, at the end of class, because you'll have time in class on Wednesday, Thursday, unless you're taking the PSAT.